hear a lot about STEAM. I'm going to tell you a little bit about how we integrate art and science at my school for kindergarten through 8th grade students. Science and art both share some really common big ideas. Scotty talked about discovery. Discovery comes into here as well. Inquiry, problem solving, and vivid communication. In both cases, there's experimentation, refinement of approach, and uncertain outcomes that have to be discovered. The second graders experiment with materials and use them to create structures to explore form and function, load, balance, and flexibility. They use this knowledge to design stable houses for the 3 little pigs that can withstand the force of a very strong wind. Isabel enjoyed taking on the role of an engineer during Ms. Damiano's unit on structures. She used wood planks to build the 3 pigs a new house, and then tested the house for strength, stability, and weatherproofing. Isabel exclaimed, "It actually passed all of the tests. It wasn't easy, but we had to make a house that was suitable for the 3 pigs, and we had to put the pig inside the house and see if it was stable when we tested it. This one was stable because we used wood." The children then began exploring computer programming using Scratch. Programming in Scratch expands the students' mathematical, scientific, and technological skills as they begin to work in the structure of computer languages. Students can use Scratch to tell an imaginary story, but in science, after studying the forest habitat up close, the students conveyed an aspect of the life cycle in the forest. When creating her science animation using Scratch, Daniela was determined to make the log decompose at exactly the same time that she changed the background. After several attempts, she was able to execute her idea and stated, "I looked at how many seconds I had and what the number was, and then I matched them up to the background so it would change at exactly the same time." Students explore the stages of design thinking with Ms. Marcel as a problem-solving tool. Define the problem, research the problem, ideate solutions, prototype, implement, get feedback, refine the solution, and then repeat as needed. Design thinking is a powerful problem-solving tool for students. They work together in teams and then identify problems, implement solutions, and reflect on their implementation. Older students do this work too. 6th graders and Ms. Pellegrino looked at Renaissance art, where there was a reconceiving of visual space with the perspective of science, juxtaposing this historical understanding with the contemporary revolution in image production via digital means, which, like the breakthroughs of the Renaissance perspective, rely on scientific advances. They insert themselves into both worlds, imagining, merging, and then sharing their new identities. 4th graders studied the 20th century breakthroughs of artists John Cage, Merce Cunningham, Jasper Johns, and Robert Rauschenberg, who created new forms of interdisciplinary collaboration between the visual arts, music, and dance. The students, with Ms. Campbell, Ms. O'Shea, and Ms. Lane, created new collaborations that included electronic music composition, digital visual projections, and rule-based choreography. And the collaborations came together only in the final performance, taking shape on stage in front of their families and friends. The 7th graders, with Ms. Goldberg, studied key innovators in science and technology, and then they present their ideas in a fair for lots of younger children, acting out the entire persona, in this case, Albert Einstein and Steve Jobs. They literally embodied the thinkers at the fair. They set up their stations all around, they answer questions, they share what they know, but they are living as these thinkers, inspiring all of the younger students and their parents. Starting in kindergarten, the children's computer programs are embodied in mechanical structures. Thus, they participate in the emerging reality in which man-machine collaboration is ever more intricate. The robot coverings are imaginatively designed, they're unique, they're expressive. Some of the robots dance, some of them compete, and all of them are enjoyed by their families, by their friends, and by the community. This group of girls presented their robot performance, dancing with their robot, at a local nursing home for the seniors, who were really quite amazed with the work that they could do. The 8th graders participate in a design process where they prototype for new school furniture. They thought about what made a better locker, what made a better desk, what made a better chair for a student, and they're iterated in stages until a final design was submitted for production. In this case, actual production, built in a factory. The children submitted all of their prototypes, their mini models, their designs, and then a company built the locker, the chair, and the desk that was the winning prize. But they didn't just win a local prize with their school, they were actually awarded a national design prize, and they were able to come and receive the award at a furniture fair in New York City. The students at the school at Columbia University learned to look at themselves and the world simultaneously, inside and out, through the complementary lenses of science and art. They experiment, they discover, they express themselves, and the teachers integrate these two disciplines beautifully.